Hi all. Okay, we'll continue with our some questions on the normalization whatever we studied. Okay, we studied already one NF, two NF, three NF. So we'll take some questions and we'll try to solve it. So here, first question is given a relation R. Okay, so with four attributes A, B, C, D. Okay, so now in general he will not give anything as a your company and SSN like that. So normally you will be getting the some attributes as a ABCD like this only. Okay, so he given as a one relation is there R with four attributes A, B, C, D and some FDC given. So, okay, in that you have first sub question that is one in that some FDs, second sub question in that some FDs we have. Okay, then he is asking you to identify the candidate keys for. Okay, so for this you have to identify the candidate keys and highest normal form. So in which normal form it's there you have to identify it. Okay, so and sometimes he will ask if it is not there in its highest normal form, maybe in 3NF or BCNF. So he will ask us to derive up to 3NF or BCNF. Okay, so up to hash normal form you have to derive it. Okay, so now we'll see. So is there in which normal form? So first one will take it. So we have four uh, attributes. So here we'll take as a B, C, D. These are the four attributes. Then we'll write the FDs whatever he given. So this is the first sub problem for this whatever FDs he given that will write it. So C to D dependency is there. Okay, so C to D. So we'll write one dependency. Okay, then next C to A is there. Okay, so C to A will write one dependency. Okay, then B to C is there. So this is B to C for writing one dependency. So like this we draw on the FD1. Okay, so here so just I insert what I will write as F1. Okay, so it's the FD1. Okay, so this is the FD2. Okay, so whatever he given, so FD3. Okay, so three things whatever he given that we return it. Now we have to identify the candidate key. Okay, so he asked us to identify the candidate key only. So identify the candidate key and then it's a normal form, hash normal form. Okay, so here first one is this is identifying the candidate key is nothing but any of the candidate key. So we have to check it for that. Okay, so now we'll go for this one is considered as a attribute A. I'm considering it. From A, can I derive remaining all the attributes that is B, C, D? Okay, so if you saw, we don't have any FDs here like that. Yeah, I can't derive it. So from A, I can't derive any of the attributes. We are not given any FDs like that. Okay, so A is not a candidate key. So now we have to check as a B. Okay, so from B, can I derive it? So from B, I can derive C. Yes, I can derive. Then from C, I can derive D. Okay, so it means from B, I can derive D because transitive inference rule already we studied. If B to C is there, C to D is there, means B to D I can get it. So it means from B I can derive C also, D also. Okay, and from C I can derive A. It means from B I can derive A. Okay, that is transitive rule. B to C is there. Okay, so C to A is there means B to A I can derive it. So this one is the candidate key. Okay, B is a candidate key. So like that I have to check it for the C also, D also. Okay, and then combination of these attributes because candidate key can be formed with the multiple of attributes. Okay, so more than one attribute will be there. So this kind of headache will be there. So instead of this one shortcut will study. Okay, so that shortcut is nothing but here we are saying as a whatever FDs are there, that FDs will write it in some graph kind of thing. Okay, so that is first FD we have as C to D. Okay, so we will write here as a from C. Okay, so from C I can derive D. Okay, so from C I can derive D. Okay, then second FD I have as a from C I can derive A. Okay, so from C I can derive A. Okay, then second one is third one is from B I can derive C. Okay, so C already here is there, so I'm writing this one here as a B. So from B I can derive C. So now you in this graph you have to check any node, okay, which has incoming as a zero. Okay, for that we'll say as a that is a part of our candidate key. Okay, and if we have like that more than one nodes, okay, so all together it will form a candidate key. Okay, so in this graph if you saw incoming degree for this one, okay, so B is 0. Okay, this is outgoing degree. Okay, B to C I am deriving it from. For C incoming degree is 1 here. Okay, so from here outgoing is there, from here also this is outgoing, for these two incoming is there. Okay, so in like this, if any node has the incoming degree 0, it means that may be a part of candidate key, or that may itself is a candidate key. Okay, so here we don't have more number of attributes in this graph, only one attribute is there that has the incoming degree as a 0, so only this is the candidate key. So here our candidate key is ck is B. Okay, so while writing also you have to write it inside a parenthesis particularly. Okay, this is the candidate key, that is a candidate key for this relation R. Okay, whatever given R is B now. Okay, the next question we had as a, that is identify the highest normal form. Okay, so highest normal form we have to identify it. So here this is a candidate key, means only one candidate key is there, and that one only will choose a primary key, so I will underline this one. Okay, so this is my primary key also. Okay, so now saying as in this is a candidate key and primary key also B in this relation R. Okay, now we have to check is it there in which highest normal form. Okay, so is it there in 1NF? Okay, so what is 1NF? So multiple attributes are not allowed. Okay, so that is 1NF. So here, okay, we'll go for the definitions. Okay, so normally multiple attributes are not allowed, or multi-valued attributes are not allowed. Okay, so that is the 1NF definition. Okay, we have say within a one relation, one more relation should not be there. Okay, so that kind of things it should not be allowed. Okay, so whatever question he given in that, if is not mentioned as a any attribute is not a multi-valued. Okay, so that is by default we'll consider as a always it will be relation R will be there in 1NF only. Okay, so now we'll consider this one is a by default these all are atomic one. Okay, so we can't divide these attributes again, so all can have the single values only, multi-valued we can't have it. So we'll consider as a, this by default whatever he given this is in 1NF. Okay, so now we have to check is it there in 2NF or not. Okay, so this is because by default whatever will be there that is in 1NF. Now we have to check is it there in 2NF or not. Okay, so now 2NF definition says, okay, so with respect to primary key we'll study it. Okay, because we already identified the primary key, with respect to primary key we will study it. So here relation R is in 2NF if every non-prime attribute A in R will fully functionally depend on the primary key. Okay, so fully functionally dependent on primary key is there or not, we have to check it. Okay, so non-prime attribute is that is nothing but here C, D, and A. Okay, these three are the non-prime attributes. Okay, so now are they fully functionally dependent on primary key or not? Okay, so that is says this here fully functional dependent on primary key or not. Okay, so now okay, we'll see from B to C is there. Okay, so C to D is there, means B to D I can get it, it is fully functional dependent. Then B to A is there. Okay, so that is why, because B to C we have, C to A we have, so this is nothing but B to A I can derive it. Okay, if I applied inference rules I can derive it. So this is there in 2NF also. Okay, so it is there in 1NF, then it's there in 2NF also. Okay, then we'll see the 3NF definition, is it there in 3NF or not. Okay, so here 3NF definition is it satisfies 2NF and no non-prime attribute of R is transitively dependent on primary key. Okay, so any non-prime attribute if it is there, okay, and is it transitively dependent on primary key or not, we have to check it. So here 1 2 3, these are the three non-prime attributes. Okay, so now we'll check here is it transitively dependent on primary key or not. C, is it a transitively dependent on primary key? B, no. Okay, because C is directly dependent on primary key here, it's not transitively dependent. Okay, what about D? D is transitively dependent on primary key. Okay, so D actually is dependent on C. From C we have a dependency for B. Okay, so it means this B is transitively dependent on B. Okay, so this violates the 3NF. Okay, so here I will mark this one as a, this violates the 3NF. Okay, now we'll change the color. Okay, so here this violates the FD1 violates the 3NF. Okay, so then same thing C to A. Okay, so here also we have transitive dependence on primary key. Okay, so this is also uh, uh, violates the transitive dependency. There is a 3NF. Okay, so now here we have to write it as a, okay, so from this one we will write as a FD1. Okay, that is here I am writing as this F1 comma F2. Okay, so violates, okay, 3NF. Okay, so and given then you have to mention as a, given R is in now in 2NF only. Okay, then you have to derive it this one to the 3NF. So you have to derive it this one is to 3NF, means transitive dependency whatever is there in this one you have to remove it. Okay, so first one whatever we have, that is the FD3 is not violating, so we'll keep as it is FD3. Okay, so FD3 will keep it here, that is B to C will keep it, and this is my primary key. Okay, we kept this one. So then F1 is violating. Okay, so this is a functional dependency. F1 is violating, that is C to D. Okay, so C to D is violating, so I will remove this one. Okay, C to D, I'm removing it, and D is dependent on C, so I can form C as a primary key here. Okay, in this table, new table whatever I'm drawing, so in this C is a primary key. Okay, then next one is FD2 is violating, that is C to A, it's violating, so I will write as a C to A. Okay, so this is new table. Okay, new table, and A can be derived by C. Okay, this is from this FD, A can be derived from C. So here in this table I will mark C as a primary key. So here we're writing as a, this is a T1 table, this is a T2 table. Okay, this is a T3 table. Okay, so we divided R into three tables, that is T1, T2, 3, and we're writing the FDs. So here we have the FD, this is F3. Okay, so here this dependency is there. Okay, so this is our C to D is F1. Okay, then C to A. Okay, so this is our F2. Okay, so this is what decomposition we did it. So whatever R we had from this one, we derived, we brought these tables T1, T2, T3. Now we have to check this is there in 3NF. Okay, so by default we have two attributes only. So here we will not get the transitive dependency in each table. Okay, so we have two attributes. We will, if you want transitive dependency, minimum three attributes should be there. Okay, so here we don't have transitive dependency. Here also we don't have. Here also we don't have. So by default this is there in 3NF. Okay, so whatever given thing is there, this is there in 3NF. Okay, so it's there in its highest normal form. Okay, so then how to mention this one is first, that is R. Okay, whatever R we had from this one we derived to. Okay, so that is different how many tables we derived, that we have to write it. Okay, we derived T1. Okay, so immediately we got T2 also and T3 also. Okay, so now you have to say as a, this one is there in 2NF. Now these three together are there in 3NF. Okay, so T1 is there in 3NF, T2 is there in 3NF, T3 is there in 3NF. So total whatever relation R, okay, which is decomposed in T1, T2, T3, it's there in 3NF. Okay, now we'll go for second question.